Hey, so I'm going to do this cool little experiment with some polymorph pellets I got. I haven't really had a good opportunity to try using it. There's a few applications for it, but you know, when you need it, trust me, when you need this shit, you need it. But you never have it. But as a woodworker, you can't recover what you take away after you cut, so you always measure twice and cut once. So polymorph is the opposite. And it's kind of like, well, you get a second chance after the fact, and I'll show you what I mean. Here, anyway, hold on. Okay, so here we are back again with the polymorph. This stuff is, I don't know, looks like barley, kind of. Barley in the raw. But it's just a low melting point plastic. And my challenge today is turning this broken latch for my dresser. I got a dresser here. This is what it's supposed to look like, but I got angry and I broke it off, trying to understand why the drawer wasn't opening, and so now I have to replace it. Anyway, back to the kettle. Okay, here we are back at the polymorph. So basically what we do, I just took out what I thought was about the same amount of plastic material that would go into making this replacement, and took a scoop of it out, and we'll just add it to this bowl of water, this bowl stuff here. And all you do is you just boil a kettle of water, and we're going to take that water and add it to this plastic. Okay, so here we are back at the bowl of polymorph pellets that we just added, and our kettle is about to boil, but just by saying that, I'm probably going to have to wait another 2 minutes for the whistle to go off. Here we go. Alright, now that we got the water boiled, we're basically just going to add a bunch of it in there, and that's it. So as you can see, it starts to go clear pretty much right away, and you know the polymorph is ready to start molding into what you want to make it into when it's fully, what's the word I'm looking for? You know how noodles, the inside cooks, the outside cooks first, and you got to cook the inside. That's what cooks last. This stuff is kind of the same as that. But anyway, this stuff's pretty much instantly ready to go, so I'm just going to start molding it. Okay, so I've taken the polymorph out. Now you might notice that the water is boiling hot, and so this thing is really warm too. You want to put it into a ball as soon as possible to keep it from cooling down too fast. But you just mold it around until it turns into one single piece. The great part about this stuff is whatever you don't use, you can just put back in the bag and use later, so there's pretty much no waste. Anyway, I'm going to start forming it into my shape now. So if you need to take a break when you're molding your polymorph, you can just put it back in the water, and that kind of puts things on hold. I'm trying to figure out whether I want to make it look a little more cosmetically pleasing or just to start carving away at it as it is. But we'll see. So once you're satisfied with how your little piece of whatever looks like, you can just set it to dry, but be careful that you don't let it stick, because it tried to stick to my countertop a second ago. So it is a little bit sticky. The first time I saw this stuff in application was in a guy who wanted to kind of glom his rocks down in an artistic way inside his aquarium. And he was actually able to put the stuff in cold water and have it mold properly for like a few seconds before it before it started going solid. But as you can see here, it started turning white again, and that's the color it'll go back to, is the kind of color of opaque rice, that hasn't been cooked. So basically, we're just going to let this cool off. I'm going to put this on top, and I'm going to start cutting out the outline of what I want it to look like. So in other words, from a woodworking standpoint, what this stuff basically is it's like primitive 3D printing, or for a woodworker it might be the opposite of where you're actually getting to create something, create a shape, a structural shape that you want to use out of bits, which is pretty handy, especially in cases where you break a part, that like this comes off like a 1970s chest of drawers, so the chance of actually finding a replacement for this in the hardware store is pretty unlikely, so pretty handy. So what I did to make sure that I was accurately cutting out a duplicate or a alter representation of what this is supposed to look like after this is hardened is, as it's been solidifying, I put just the surface on there and I pressed in a little bit and ran around the edge with just a butter knife, just so I tried cutting it, but it doesn't want to cut when it's kind of midway through its solidifying point. And that way I'll kind of have an accurate representation on where the holes are supposed to go and where the little sliders are, and at least just a general idea on how I'm going to be filing out the outline for how I want these little hooks to be, because the hook part is the most important part of this. It's irritating the crap out of me, opening and closing my chest of drawers.
So here we are with the finished piece of plastic. I basically used a Dremel tool to wear down the little divots here. And the interesting thing about Polymorph that I noted using a Dremel was it doesn't come off like shavings like for wood. It heats up and turns into a putty which you can kind of just remove with your fingers. And then you make these cute little piles of a lot of similarity to what the Polymorph was originally manufactured to come in. These little pellets, so you can just put them back into your bag and reuse them. So there's pretty much zero waste in this in the creation of this little piece. So this is to replace this piece here. So we've basically just starfished a new one, and I've tried it in the drawer, and it's a pretty good fit. And I think this plastic is actually going to do better because this plastic it's a little bit flexible, right? So it has a bit of tensile strength, whereas this one's really old and brittle in comparison. So hopefully this does what I needed to do. And for anybody who's considering using Polymorph, fantastic product to keep on hand if you've got old pieces of plastic or discontinued pieces of something you need to replace. This took me about an hour to fabricate to how I wanted it, and it works. So yeah, I now have a working chest of drawers, which is doesn't have an orphan chest, so that's good. Happy ending. So I just want to elaborate a little bit more on this material when you're using it. It really doesn't like to have material removed. It does not remove material when you're using machining bits on it or anything powered. It will displace the material. So for instance, when you're putting in these screw holes, like when you're tapping the holes with a drill bit, you're not going to be taking away material like that you're kind of seeing there. Well, you might get a little bit, but you're just basically moving the plastic out of the way so that you can fit a screw through. Now, I'm not sure if it's a strength or not for the material, but when you screw into there, it's still semi-plasticine, liquid plastic, if you put a screw in right away. So I'm not sure if this is a strength for this material, in that to some degree the plastic is going to reform around the screw after you've screwed into it. That may be a plus for some, it may be a minus, but I think it actually would be a good thing for just integrity of the material. So once you put a screw in there, if you put the screw in right away, that's what's going to happen, is it's going to be slightly plastic, and then now, you know, like between 30 seconds later, I guess, it'll be dry, and it'll be fully hardened. So, yeah, just something to watch out for.